Hello everyone. In this video we're going to be going over some additional graphing features questions. So in this case we're given the function f of x is equal to 2/3 x plus 2. Now what I've done is make a very rough sketch of what this graph looks like. This could be something that we do by hand, something that we use our graphing calculator for, or a website like Desmos to just type the function in to have a better idea of what it looks like when we're answering these follow-up questions. So we're going to start right away with number one, which says over which interval is f of x greater than 0? And then kind of like a separate part, over which interval is it less than 0? So what is this saying first? The first question is saying, when is this function going to be basically over the x-axis? Okay, it's saying the y values are positive, right? So where does this have y values? Where does this have outputs that are, because remember we're associating this with outputs, we'll call them like y values just to better understand it for now. So where are the y values greater than 0, meaning basically over the x-axis? That's going to happen all over here, right? Those are all the values where the y values are going to be greater than 0. That's all the locations where y is going to be greater than 0. So when does that happen? What's kind of the boundary point for this? It's happening right here. Everything past this, y is going to continue to be greater and greater than 0. It's actually getting larger and larger along the way. So that's a y value of -1, -2, -3. So from -3 until infinity, it's not like it's going to dip back under the x-axis somewhere over here. It's getting larger and larger. From -3 to infinity, this graph is greater than 0. F of x is greater than 0. The y values are going to be greater than 0 from -3 to infinity. We can alternatively write that like this. Now, where's f of x going to be less than 0? Same idea. Now we're talking about this. So where is it under the x-axis? Once again, where are the y values below 0? That's going to happen from -infinity up until 3. So it's almost like an increasing, decreasing, which if you look is in question 4, kind of the same idea, but in a different light. We're giving an interval, but now it's in regards to 0. We're not necessarily saying, obviously this graph is always increasing, which we'll talk about, but we're providing this interval of where something is happening. What are the roots of this function? Roots mean where basically the x-intercept, right? Where does y equal 0? And we already identified that, so we could just say the root is 3. There's only one root. Say x equals 3, something along those lines. You could give it as a coordinate. Excuse me, not 3, -3. Just kidding. So you could say x equals -3. You could say -3, 0. A root is just an x-intercept, also called the zeros of the function. What is the y-intercept? This one we should be able to spot just by looking at the equation itself. Even if we didn't have a sketch, we know that this +2 in front represents the y-intercept of the function. So the y-intercept here is 2. That's where it hits the y-axis. And now over which interval is the function increasing or decreasing? So this is a line. We looked at some crazy looking curves in class today, but for a line, this is always increasing. This has a positive slope no matter where you look. So this is never going to be decreasing. It's always increasing. So how would we represent the fact that that's always happening? How can we write that? What we can do is say between negative and positive infinity. Remember, anytime we talk about, just like number 1, anytime we talk about a function doing something, unless otherwise noted, it's in regards to the x values. So we're going to say, hey, this is happening all the time, from -infinity all the way to positive infinity. Alternatively, you could write this. Small numbers on the left, larger numbers on the right. This is always increasing. Could also say all real numbers. Okay. So that's everything for f of x here. It does help to have a sketch like this. Like I said, maybe having your graphing calculator in front of you, looking at even just a table of values, making a rough sketch. You know, you could do this one pretty quickly like I did. We know that it begins at 2 and there's a pattern of up 2 over 3 if we think back to slope. Sometimes having in front of you is going to help with these questions like this if you're not provided with a graph. Okay. Now it looks like we're looking at a quadratic function here. We have a parabola. It's called h of t. So t is our variable here, where t is time and h is height. So it says, how long is the rocket in the air for? So we're kind of reading a graph here. So it looks like that it's fired at the very beginning here, obviously, reaches a maximum height, and then obviously, due to gravity, it falls back down. So how long is it in the air for? This is 10 seconds. So it looks like this whole event takes place over 12 seconds. What is the maximum height? Maximum height we talked about as a graphing, not maximum height, but a maximum of a function we've talked about as the highest output or the largest output of a function that happens, at turning points, or a minimum is another type of turning point. But in this case, it's like the top of a mountain, and that's occurring. Be careful with your scale here. It looks like it's going by tens. So I'm going to say that's one tick under 200, which would be 190. Just verify, it looks about right. 190 unit here is meters. And then find the intervals when h of t is increasing and decreasing. Explain what this means in context. So it's increasing on the left-hand side, right? That's between 0 and 6 seconds. And it's decreasing on the right side. That's between 6 and 12. I don't want to say infinity. You might be saying, like, doesn't it keep decreasing? Because this is a real world situation, once this ball hits the ground, this event is over. It's not like the ball continues to go underground. Now, what this means in context is between 0 and 6 seconds, the rocket here is rising, increasing in height. Between 6 and 12 seconds, the rocket begins to decrease in height, falling back down to the ground, and ultimately ending after 12 seconds. And that's everything for today on basically a follow-up, a continuation of what we talked about in our previous lesson on graphical features. I'm just going to go back to that slide. We saw this in class today. So just recapping all these points, really driving them home one more time here. Increasing and decreasing is always in regards to the x values. Okay, we don't include the actual values. You might see a question or two where I've seen that happen sometimes where it doesn't make it a trick or anything, but like all the choices just have that equal to / underneath them, which is a little weird and doesn't really make sense. But for our purposes now, we're not going to include the boundary points. I kind of said they're like neutral. They're neither increasing or decreasing. A vertex or a turning point means the same thing. Is basically the top of a mountain, the bottom of a valley, where a function switches between increasing or decreasing, or vice versa, right? It's that transition, basically that neutral spot that we were just talking about. There's 3 words for roots. We have roots, zeros, or literally x-intercept. That's where the graph hits the x-axis. For that, you can just say the number. It's a little less common to actually write it as a coordinate. It's a little redundant, but I suppose you can. Now for maximum and minimum, that's going to be for maximum, the largest output. For minimum, the smallest output for the graph. And this is very important. It's always in regards to the y value. So unless otherwise noted, you don't want to give that as a coordinate. If I said, what's the maximum here, your answer should just be 7. All right, that sums up graphical features. You guys are going to work on an assignment where you're analyzing a graph and answering some follow-up questions. So please feel free to re-reference this if you have to, or the slides from this lesson that are available in Google Classroom. Thank you guys for watching, and have a great day.